In this video, we're going to be discussing the confidence interval estimate for the mean when our standard deviation is known. So our real question that we want to know is, if we do not know the population mean, mu, can we estimate it using our sample mean? And moreover, what does it mean when we say that we are 95% confident that the mean is within a certain interval? Well, let's take a look at this picture and try to determine what this may mean. So we have a normal distribution here, and what if we took our 95% interval that is symmetric about the center here? Then we have 95% in between, we have 2.5% below this line and 2.5% above this line. Between here is 47.5 and here is 47.5. Now, why do I write that out? Well, we want to know the z-scores at those values. Those are negative 1.96 and positive 1.96 respectively. Then, what can we do with that? Well, if we take all of the samples, so we have a population, and we do samples of certain sizes. So if we take all of the samples of that certain size and find an interval, x bar plus or minus z times sigma over root n, where x bar is the sample mean, z is this z-score, which is negative 1.96, or really positive 1.96. Sigma is our standard deviation for the population, which we somehow know already. And n is our sample size. So we take this interval, right? This is plus or minus, so we get x bar minus z times sigma over root n, all the way up to x bar plus z times sigma over root n. And we find each of those intervals for each sample mean when z is 1.96. Then we know that 95% of all of these intervals will contain the population mean. So that's what we mean to say that we are 95% confident that the mean is within a certain interval. If we have all of this data for a sample, then we can determine the interval for that sample. If the mean is within that interval, then we can say we are 95% confident that the mean is within that interval, as long as the z-scores we chose originally correspond to this 95% interval. So as long as we use z is equal to 1.96. All right, so we want to do one example here, but I'm going to change it up a little bit. Now, instead of doing 95%, we're going to do a 99% interval estimate. So here is our example. If x bar is 125, sigma is 24, and the sample size is 36, we want to construct a 99% interval estimate for the population mean. i.e., we want to construct an interval that we are 99% sure the mean is within this interval. The actual true population mean is within that interval. So how do we do that? Let's think about this picture again. And you don't need to draw this picture every time, but for this first example, we will. So here we want this region to now be 99%, which means that we want 1% to be on the outside, or in other words, 0.5% to be below and 0.5% to be above this interval. This corresponds to the z-scores negative 2.58 and positive 2.58. So we want to construct our interval using using positive 2.58. We're getting the negative from just the add or subtract here. So the add is the positive, the subtract will give us the negative. So we just plug in positive 2.58 for z into this equation, and we'll get our interval. So this is really equal to x bar in the problem was 125. So we get 125 plus or minus 2.58 times sigma. Sigma that we were given was 24, all over the square root of the sample size, which was 36. And so really, we have 99% confidence that mu is in the interval, so the population mean is in the interval 125 minus 2.58 times 24 over 6, all the way to 125 plus 2.58 times 24 over 6. And of course, plug those into the calculator to find what those exact values are. 4 times 2.58 and subtract that from 125. And over here, add that to 125. And we know what our population mean probably is. It is probably, as in 99% chance that it is within this interval. And the last thing I'll say before we end this video is, when might this be useful? Well, generally this might be useful if we don't know what the population mean is, because that might be hard to do. So we can estimate what the population mean is by finding some samples and finding their sample mean and then doing this calculation. But unfortunately, in this problem, what we've done is we've used sigma. Sigma is the population standard deviation. To actually know that, we need to know the entire population to be able to calculate that. In other words, if we did know that, we could calculate what the population mean was in the first place. So in practice, this exact method is not going to be useful. We'll see how to come up with a similar method in a later video that will be more useful for practical applications. But we just want to do this section so that we can start to understand how we might be able to solve a question like this. And that ends this video.